Okay, so in this task, the purpose is to use the balance software to visualize the problem that A, C, B, and D are static points and E is dynamic. And we want to know how far to place E from A, here's our distance measurement here, so that the sum of the distances from C to E and from E to D, which can be measured right there, is at a minimum. So here it's at 9.8, 9.2, and then back over here it goes down and up. So probably somewhere in here by looking at it, but we'd like to be much bigger. So one way to go about doing that is to look at graphs. So what you can do is you can take this distance measurement, AE, and you can take that sum, and you can plot it as a point XY, and I can move it around. Okay, so this point's traced right now. So if I went right there, you can see 2 is representing, here's 2, that's the distance from A to E. And 8.93, that's the sum that we're looking at, that's the Y value here. So by tracing the point, what it makes you can do is when I move E back and forth, that is all of the possible points that you could have, given from the domain of 0 to 6. So this makes it kind of nice to be able to talk about domain as well. But as far as this task is concerned, we would like to know where you need to be so that this is a minimum, which would be right at the bottom. And in this case, it is right at 4, or right about there. So using the software, you don't have to get into Pythagorean theorem and making equations and everything else. That would be a much harder task to get the idea of what the minimum and plotting point. Now, for more advanced students, they could make that formula, or they could make the equation and find the minimum of it. Or they another thing you could do using the software is, having already done this, you could make the equation and show that it really does correspond to those plotted points. So I'm going to do that. So using Pythagorean theorem, if AE was, I'm thinking of that as X, and CA is 4, then I would have the square root, because it's Pythagorean theorem, of X squared plus 16. And then the other side, since DB is 2 and EB would be the rest of it, of 6 minus X, I have the square root of 4 plus 6 minus X squared. And isn't that nice? It corresponds perfectly to all those plotted points. And we can talk about this being the entire function, even though for the purpose of this, the domain for this task, the domain is only going from 0 to 6.